We often hear that LLMs are black boxes, but they do not have to stay mysterious. In this video, we will open them up brick by brick, just like taking apart a toy or building with Lego. We will start with simple ideas like tokens, then move into how text becomes numbers, how transformer blocks process information, what logits are, and finally how a logit lens helps us peek inside the model while it is thinking. The article begins with a very relatable idea. Sometimes the best way to understand something is to take it apart and inspect the pieces. Just like toys or Lego builds, LLMs also become less intimidating when we stop treating them as magic. Instead of seeing one giant black box, we look at smaller parts working together. That mindset is the key to understanding modern AI properly. At the most basic level, an LLM is a machine learning model trained on huge amounts of text. It does not understand language like a human being does. Instead, it becomes very good at spotting patterns in text and predicting what should come next. So when it answers a question, writes code, or summarizes a paragraph, underneath all that it is still doing a prediction task again and again. Before an LLM can process language, it first breaks text into smaller units called tokens. A token can be a full word, part of a word, punctuation, or even a special symbol. This is important because the model does not directly read sentences the way we do. It reads a sequence of tokens. So if you want to understand LLMs properly, tokens are the first bricks you must get comfortable with. A very powerful way to think about an LLM is this. It is a next token predictor. You give it some context, like a prompt or a sentence beginning, and it predicts the most likely next token. Then that new token becomes part of the context, and the process repeats. This is how one token turns into a sentence, one sentence into a paragraph, and one prompt into a full response. Now that we've covered LLM basics, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. What is the main mindset encouraged in the article for understanding LLMs? The correct answer is, break them down step by step. The article compares understanding LLMs to taking apart toys or building with Lego, meaning we learn by examining the pieces. Question 2. What is an LLM fundamentally trained to do? The correct answer is, predict language patterns. An LLM learns patterns in text and uses them to predict likely continuations. Question 3. Which statement about tokens is correct? The correct answer is, tokens can be words, parts of words, or symbols. Tokenization breaks text into manageable units, and those units are not limited to full words. Now comes a crucial shift. LLMs do not operate on plain text directly. Once text is tokenized, each token is mapped to an ID, and then those IDs are turned into numerical representations, often called vectors or embeddings. This is how language enters the model in a machine-readable form. So the sentence you type is first converted into structured numbers before any real computation begins. The article points to the transformer block as the real engine room of the LLM. This is where the token representations get processed layer by layer. Each block updates the model's internal understanding of the sequence. As information passes through many such layers, the model gradually builds richer context, stronger relationships between tokens, and a better sense of what token should come next. After the model processes the input through its layers, it produces logits. You can think of logits as raw scores assigned to all possible next tokens in the vocabulary. These are not probabilities yet, but they indicate which tokens the model is leaning toward. A higher logit means the model currently prefers that token more strongly than others. From these scores, the final output token is selected. Now that we have covered inside processing, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. Why must text be converted into numbers before model processing? The correct answer is, because models only compute on numerical representations. LLMs are mathematical systems, so tokenized text must be transformed into IDs and vectors before computation. Question 2. What is the role of a transformer block? The correct answer is, it processes and refines token information layer by layer. Transformer blocks are the core units that update internal representations as the sequence moves through the network. Question 3. What are logits in an LLM? The correct answer is raw scores for candidate next tokens. Logits are the model's raw preference scores before converting them into probabilities or choosing the next token. A logit lens is a very interesting interpretability idea. Instead of waiting for the final layer only, we try to inspect what earlier or intermediate layers are already predicting. In simple terms, it lets us look inside the model while the thought process is still forming. This helps researchers and practitioners understand how predictions evolve across layers, and it makes the black box a little more transparent. The big takeaway from the article is not just one technical term, but a new perspective. LLMs become easier to reason about when we follow the journey. Text becomes tokens, tokens become numbers, numbers move through transformer blocks, blocks produce logits, and tools like a logit lens help us inspect the process. Once you see this flow clearly, you stop using LLMs blindly and start understanding them with confidence. Now that we've covered full picture, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which sequence best matches the article's explanation of LLM processing? The correct answer is text to tokens, to numbers, to layers, to logits. That sequence captures the core pipeline described in the article. Question 2. What does a logit lens help us do? The correct answer is inspect predictions at intermediate layers. A logit lens is used to peek into the model and see how predictions are forming before the final output layer. Question 3. What is the article's overall goal? The correct answer is to explain LLMs layer by layer. The whole article is about breaking down LLMs step by step so they no longer feel like black boxes. So the next time someone calls an LLM a black box, you can say, not exactly. If we open it brick by brick, the system starts making much more sense. Keep exploring with curiosity, and you will find that even complex AI ideas become manageable when broken into simple parts.